Analysis of indeterminate structure class. Today topic is moment distribution method. This is second module. What is moment distribution method? We are going to calculate the moment for continuous beam by using this moment distribution moment. In the topic only the meaning is there, moment. Whatever moment occurred in the joint, we are going to distribute on the continuous beam. Let us take or note down the important points in your notebook, and let us see what are the steps or comes in the moment distribution method. In this method, very first we should understand the relative stiffness. For calculating relative stiffness, we are using this formula K is equal to I by L. But here some conditions are there. If far end is fixed, or continuous support, K is equal to I by L. If far end is not continuous support, that means the support is hinge or roller or simple, then the relative stiffness or K is equal to 3/4 of I by L. If far end is overhang, K is equal to 0. Okay, you should remember these conditions when we are going to solve the problem. Then you are understanding, or these conditions are applying according to the given support condition. So you should remember these conditions, and also you should note down these conditions in your notebook. Next, if continuous support, take one example like this for your understanding purpose. Here given one example how the relative stiffness we are going to take. See, observe, this is the continuous beam given. The support E is fixed and support B is roller and support C is hinged and CD is overhanging. With respect to A, B is continuous, K is equal to I by L. With respect to B, that means with respect to B support, A is fixed, so K value is I by L. C is not continuous, so the K value is 3/4 of I by L. With respect to C, B is continuous. With respect to C, B is continuous, K is equal to I by L. And D is overhang, K is equal to 0. See, this is just for your understanding purpose, given an example. Okay. Next, carry over of moments. Whatever moment occurred in the joint, those moments we are going to carry over towards both the span or both the joints. Observe this one example given here. The continuous beam is given here. The joint A is fixed and joint B is roller and joint C is simply supported. In this condition, in this support condition, in the continuous beam, how the moment will carry over? See, in this condition, if the support here, I want to carry over the moment whatever occurred in the joint B. So that is my moment M. How we are going to carry over towards other joints? According to the load condition. It also according to the load condition applicable. If the support, according to the support condition, if the support is fixed support, if the support is fixed, then the moment will carry half of the moment B. Okay, that means M by 2. If the support is not fixed, that means if the support is simply supported, simple support, then there is no any moment carry. Okay, so that is 0, not continuous. Okay, if the fixed or continuous, you can carry the moment. You should remember this condition. If the fixed or continuous, for example, if this beam is continuous, then also you can carry over, but here not fixed support and also not continuous. If far end is fixed or continuous, then transfer 50% of moment with same sign. Okay, it is very important, don't change the sign. If far end is not continuous, then there is no transfer of moments. Then there is no transfer of moment. Let us take one example. Analyze the continuous beam shown by moment distribution method. And the line diagram is given like this. This is continuous beam. The support is fixed support and support B is roller, support C is hinged support, support D is fixed support. And on the span AB 4 meter, the load applied UDL 50 kN per meter, and on the span BC, the point load is applied. It is not exact center, it is 2 meter from support B. And on the span CD, the point load is applied 80 kN at the exact center. Okay, that means the total CD span length is 5 meter. Okay, this is the given problem. Very first you should analyze the given problem first. What type of problem it is, that means what type of support conditions are there and what type of loads are there. You can think about that first. After you can move to next step. And in the exam also same way question will arise. Okay, question will give same way means same type. Just the support conditions and the load conditions are going to vary. Next, by using moment distribution method, these are the steps we are going to use. Here also we are going to calculate. The first step we are going to use calculating fixed end moment. It is common, whatever we studied in the last method, slope deflection method, the same procedure and the same formulas you should use here also for calculating fixed end moment. So that is the reason I am not once again explained here very briefly, so directly I wrote here I wrote direct calculated answers. You can write the formula and substitute the values and check the answer. You should use your calculator and calculate every step, every moment. Okay. Next, after calculating fixed end moment, next step is second step, or step B is distribution factor for intermediate support. Okay, this distribution factor is for intermediate support. Here, what are the intermediate support? Which are the intermediate support in this problem? The support B is support B and C are the intermediate support. So you can take joint B and joint C. Here, joint B member BA and BC, and in the joint C member CB and CD. You should write down this table. Okay, the joint member relative stiffness or K, and summation of K, and distribution factor is K divided by summation of K. This is the table for calculating distribution factor. Here, for calculating relative stiffness, very first I said or I explained how to calculate relative stiffness, that depend on according to the support condition. So you can once again recall that and apply the relative stiffness factor here. See here, the relative stiffness we are going to use I by L. Why I by L? The support is fixed. That means if we are going to consider joint B, BA, you can see the line diagram or this continuous beam. The support A is fixed and support C is continuous here, hinged support, and also it is continuous. So the relative stiffness factor you are going to use I by L only. Okay. If not fixed or not continuous, then you are going to use 3/4 of I by L. That is the difference. It is very simple. You should remember. Okay. So here I use that factor is I by L. After you can substitute the data. I not given in the problem. You can keep it as the constant I only. The length is given. BA span length is 4 meter, and here the BC span length is 6 meter. You can substitute and calculate the answer. Here you can take I out, that means 1 by 4. 1 by 4 is nothing but 0.25 I. Here 1 by 6 I, that means 0.167 I. Okay. After you can summation of K. You can add the both the values. You are getting 0.417 I. After the final column is distribution factor calculation. The formula is very important. You should remember, and every problem you should write this table. It is compulsory. Okay. Distribution factor is how to calculate distribution factor. The K divided by summation of K. We know we already calculated both. That means we have relative stiffness K and also summation of K. So you can substitute according to that. The first for member BA, K value is 0.25 I, and divided by summation of K is 0.417 I. So here II will goes to cancel. So remaining is 0.25 by 0.417. Calculating this relation, you are getting answer 0.60. Similarly, here also you are getting answer 0.40. Okay. And coming to joint C, here member CB and CD you are going to take, and the relative stiffness factor is I by L, and substitute the data and calculate the relative stiffness K value. After you can add take the summation of K and calculate the distribution factor similarly. Okay. I hope you understand this step. You can once again watch the video and try to understand. It is very simple concept, but you should remember the conditions. Conditions are very important according to the support condition. So the condition you should remember and apply those condition and follow the procedure. Okay, the procedure is very simple but quite lengthy. By it comes by just practice. You should practice. Okay, write down in your notebook and practice, and use your calculator. It is very, very important. In the exam also you are going to fail by using calculator. Use your calculator and solve every step individually, and after getting answer you are compared to this answer if it is right or wrong. If you have any doubt, please ask me, or you can contact in offline classes. Okay, thank you. Happy learning.